Hello guys, good day to you. You're welcome to this channel again. Today we are looking at how to factor trinomials, which factor out as perfect squares. In our previous tutorials, we had looked at how to factor trinomials where the leading coefficient is 1. Also, how to factor trinomials where the leading coefficient is greater than 1. And in the last one, how to factor difference of two squares. All these are quadratic expressions. To start this tutorial, we need to know what perfect squares are. A perfect square is any number, any variable, any quantity that can be expressed as a square. We have examples. 4 can be expressed as a square, which is 2 squared. So 2 squared is a perfect square. We've got 3 squared as a perfect square. What of x squared? It is a perfect square. Or do we want to talk about x minus 1 all squared? This is another perfect square. Now, we will try by expanding a perfect square to see the behavior of perfect squares when they're expanded. And once we see the behavior, we'll be able to use that to generalize to how to factor such expressions into perfect squares. So to do this, x plus a squared can be written as x plus a multiplying another x plus a. Then by the distributive property, we're going to take x from the first bracket to multiply every item in the second bracket, plus a in the first bracket multiplying x plus a, the second bracket. Then opening the first, we've got x squared plus ax. And the second one is going to give us plus ax plus a squared. And this is x squared plus 2ax plus a squared. Now take a good look at the expansion. The first term in the expansion, x squared, is the square of the first term in the bracket. The last term of the expansion, a squared, is the square of the second term in the bracket. Then the middle term is twice the product of the two terms in the bracket, a and x. One more, x minus a all squared. This can be written as x minus a times x minus a. And using the distributive property again, we have x times x minus a times x minus a. Then opening up the brackets, we've got x squared minus ax from the first bracket, and from the second bracket minus ax, then minus a times minus a gives plus a squared. And simplifying gives us x squared minus 2ax plus a squared. Again, we'll notice here that the first term is x squared, which is the square of the first term in the bracket. The last term, a squared, is also the square of the second term in the bracket. However, in the middle, we still have twice the product of the two terms, but this time around with a minus. Now, let us talk about the findings from these expansions. In the first expansion, we have something like this, where the first term is the square of the first in the bracket, the last term is the square of the second term in the bracket, the middle term is plus twice their product when the sign is plus in between them in the bracket. So in general, we can say that the square of the sum of two quantities is the sum of their squares plus twice their products. Also, when it is a minus between them in the bracket, the first term is also the square of the first term in the bracket. The last term is also plus the square of the second term in the bracket, but the middle term is minus twice their product. So these two are important products, important findings when it comes to factorizing quadratic expressions or trinomials that factor out as perfect squares. So once a trinomial satisfies this condition, the first term being the square of a particular quantity, the last term being the square of another quantity, and the middle term being twice the product of those quantities, then they factor out as a perfect square. The sign with the middle term determines the sign in the bracket when we factor out the perfect square. Let's take a look at some examples. In the first example here, we want to factorize x squared plus 8x plus 16. Let us start by analyzing each term. Now, in analyzing each term, x squared is the square of x. Then let's go for the last term. 16 is the square of 4. Then the middle term, 8x, is 2 times x times 4. That is twice their product. This satisfies the condition for perfect squares, and therefore x squared plus 8x plus 16 is going to factor out as a perfect square, which is going to give us x. The sign in the middle will be plus because we have plus 8x, x plus 4 all squared. Another example is here, but let us analyze it first. 9x squared is the square of 3x. $25 is the square of 5. Then let's go for the middle term, 30x. This is twice the product of 3x and 5. This also satisfies the condition for perfect squares. So that 9x squared minus 30x plus 25 is going to factor out as 3x. Then this time around is going to be a minus because we have minus before the middle term. 3x minus 5 all squared. Here is an exercise for you. Factorize the first one, x squared minus 2x plus 1, 2, 4x squared plus 12x plus 9. Let us know your solution, your answer in the comments below, or you can forward it to the email attached to the description. Keep enjoying our tutorials. Share the videos, share the tutorials. Subscribe to the channel if you are yet to do so. Then watch out for more tutorials on trinomials or quadratic equations in the coming days. But for now, bye.